The overall goal of this procedure is to demonstrate the integration of photoacoustic ophthalmoscopy with spectral-domain optical coherence tomography for simultaneous in vivo imaging of the retina in small animals. This is accomplished by first preparing an anesthetized animal by dilating the pupil and paralyzing the iris sphincter muscle. Then, real-time SD-OCT cross-section imaging is used to locate the retinal region of interest and to optimize the optical parameters. A needle ultrasonic transducer placed in contact with the animal's eyelid detects the laser-induced photoacoustic signals and optimizes the position of the ultrasonic transducer for maximal signal amplitude. The final steps are to set the scanning parameters and acquire SD-OCT and PAOM images simultaneously. Ultimately, the optical absorption contrast and optical scattering contrast from the collected images can reveal minute functional variations in the retinal circulation and pigment epithelium together with detailed retinal anatomy.
Photoacoustic ophthalmoscope is a newly developed ophthalmic imaging modality. This technology can reveal the optical absorption contrast of the retina, and thus has a potential advantage over existing modalities in imaging the retinal choroidal vascular network and the retinal pigment epithelium.
Spectral-Domain Optical Coherence Tomography (SD-OCT)